Greetings, Earthlings. Today we're going to have a look at the Nova 445 and see it actually run some code. Let me switch this off because we're not going to be using it, and it's just making noise. It's been a while since I've done a video here, and I've been busy on other things. But what I've done is I've fashioned a minimal front panel, as it were, and I've written some code. I've got all the chips installed. There's some EEPROMs here, some RAM chips here. We're not actually going to be using the RAM. I've written a little 8-step program. Let's see if you can see that. There it is, just to test it. And what it's going to do is just blink the carry LED. You can see there the LEDs that I have: power, run, interrupt on, and carry. Those are over here. Those are right here, these LEDs. There's a reset button here, and there's we'll call that a program load or whatever button there. What program load does is it starts execution at the highest memory address, which, since this is an octal machine, is 077777. Then I'll jump back to here. This is just for testing. Jump back to here. This does a jump to subroutine down to here. That jumps back relative. So jump to subroutine stores the return address in accumulator 3. This is a jump relative to accumulator 3, 1. So the return address would have been here. When I say jump 1, 3, it should come back to here. And then it just clears accumulator 0 and increments it and loops forever. What'll happen when that overflows, so 65,536 loops later, the carry will get complemented, and it'll keep going. And so every 65,536 times around that loop, the carry will flip, and we should see it blink. It did take me a while to get here. As you can see, I have the logic analyzer hooked up, and I probably could have found the problem without it, but it made it easier. I made a mistake. On the ROMs, there you go. There's the schematic. On the ROMs, I wired up the data lines backwards. The Nova is what they call a big endian machine, and these are a little endian. Big endian means that bit 0 is the high order bit. Little endian means bit 0 is the low order bit. If you're not familiar with that terminology, I recommend you search out on the web an old paper by Danny Cohen of ISI called, if I remember correctly, it was called "On Holy Wars and a Plea for Peace," which talks about this. Anyway, I connected what the PROM programmer thinks is the low order bit to what the computer thinks is the high order bit, and so on. In fact, these are just arbitrary bits. I could have connected them up any way I wanted to, but it's nice to be consistent across the various pieces of equipment, and so the PROM programmer and the computer disagree. So I had to go and manually reverse those bits. In practice, it's not a fatal flaw, since I'll probably need some sort of conversion program anyway to take the output, whatever output I get from the assembler, and convert it to the format that the PROM programmer wants. I can do that bit reversing there. Or I can put lots of little blue wires on the underside of the board and reverse those lines. Or I can make another revision of the board. None of that seems necessary. The first one seems the simplest. Do it in software. Okay. There's the good old, bad old power supply over there. Now you'll notice maybe that I have it set to 5.1 volts and current limited at 1.3 amps. This thing does draw about an amp, and then I have a voltmeter here. These are not the leads that came with it. The leads that came with it are right here, and they're garbage. Okay, there's about a half ohm of resistance in those leads. So when the thing is drawing an amp from the power supply, there's a half volt drop on these leads, which is not good. The processor wants plus or minus 5%, so 4.75 to 5.25 volts. There's still a little drop in here, so I've bumped it to 5.1 volts for the power supply to put out, and we can measure the actual voltage once it hits the board on this meter here. So if we power it on, we'll see we're drawing 950 some odd milliamps, 4.975-ish volts. That's fine. The power LED is on. Okay, so there's a power on reset. There's a capacitor in there, which provides a power on reset. But I can press that reset button as well. And so if I press this button here, we'll see that LED blink. So power, run, it's running. Interrupts are not enabled. And this is the carry bit, which is just incrementing. I filled the rest of the ROM memory with halt instructions, so that should it go somewhere I don't expect it to, it should just immediately halt. And obviously it's not doing that. The fact that it blinks tells me, even without tracing it with the logic analyzer, tells me that it's running to some level. I'm not accessing any RAM here. I'm just using registers. So we don't know that the RAM works. And we can also see here that it's drawing a little over an amp right now. So, oh yeah, the other thing about this power supply, see, I set it to 5.1 volts. It now says it's 5.3 volts. The reality is it's probably about 5.1 at the terminals there. But by the time it gets over to here, it's down to about 5. So maybe about 0.1 ohms resistance in those leads. Okay, so let's do one more thing. I can press reset here, and we'll see that stops it and takes it out of run. Okay, so. Yeah. So that's your status update on the Nova 445 for now.